Hello friends, welcome to H2 Event Academy. In the last lecture, we have started the discussion on the symmetric group. So let us proceed further. So what we have seen in the previous lecture is that Sn is a group under operation composition of function. By this we mean Sn satisfies all the four properties for being a group. That is, it satisfies closure property. Second one is associativity. Third one is existence of identity element. And fourth one is each and every element has its inverse. Okay. So let us verify this for S3. So in the last lecture we have calculated the elements of S3. So we have the elements of S3 as S3 contains all the bijections from three element set, that is 1, 2 and 3 to a three element set 1, 2, 3 under operation composition of function. Okay. So this star is the composition of function. We have seen that the order of a Sn is n factorial. So order of S3 will be 3 factorial, that is 6 elements are there. And in the last lecture we have calculated the elements of S3. So we have this as, so these are the bijections F1, F2, F3, F4, F5 and F6. So in the last lecture we have calculated all the bijections of all the bijections that are contained in S3. So we have this as F1, F2, F3, F4, F5 and F6. So these elements, these are the bijections. These bijections form a group under operation composition of function. So S3 is a group under operation composition of function. Okay. So now let us show that this S3 satisfies all the four properties for being a group. Okay. So let us show this. So we have first one is S3 satisfies all the four properties for being a group. Okay. So S3 satisfy all the four properties for being a group. So the first one is closure property. Okay. So we have composition of function. Composition of function is a binary operation. Hence S3 is closed under operation composition of function. Okay, so S3 is closed under operation composition of function. Okay, so let us calculate the mapping F2 F5. Okay, so on F5 we have to apply F2. Okay, so let us write down the mapping F5. This is F5. This is 1, 2 and 3, 1, 2 and 3. On F5 we have to apply F2. Okay, so F2 is being applied on F5. Okay, and this is nothing but this mapping from this one to this one is F2 or F5. Okay, so we have in F5 we have 1 goes to 3, 1 goes to 3 and 2 goes to 1 and we have 3 goes to 2. Okay, here also 1, 2 and 3. Now let us apply F2 mapping. So here 1 goes to 1, 1 goes to 1 and we have 2 goes to 3, 2 goes to 3 and we have 3 goes to 2. Let us calculate this one F2 or F5. Okay, so F2 or F5 is let us write down here. This mapping is F2 or F5. 1, 2 and 3. This is 1, 2 and 3. Okay, so here there 1 goes to 3 and 3 goes to 2. This means 1 goes to 2 and we have 2 goes to 1 and 1 goes to 1. This means 2 goes to 1 and this is 3 goes to 3. So this is nothing but F4. Okay, here 1 goes to 2, 1 goes to 2, 2 goes to 1, 2 goes to 1 and 3 goes to 3. So this is nothing but F2 or F5 is equal to F4 and this F4 is contained in S3. This means S3 is closed under operation composition of function. Now let us discuss associative property. Associativity. Okay, so the composition of function is associative. Composition of function is associative. Okay, so we have, let us write down as like this: f1 o f2 o f3. Okay, like this is equal to f1 o f2 o f3. Okay, if we calculate both the mapping, both are same. Okay, now let us discuss existence of identity element. Existence of identity element. Okay, so we have this clearly, f1 is the identity element. So we have the mapping like this: 1 2 3. So 1 goes to 1, 2 goes to 2, 3 goes to 3. This is nothing but the identity element. f1 is the identity element, and this is contained in s3. Okay, this means s3 is having a identity element. Now we have to show every element is having its inverse. Every element is having inverse. Okay, let us calculate. f1 is identity element. Okay, let us calculate f2 square. This is f2 operation f2. So we have the operation f2 as, this is f2. On f2 we have to apply again f2. So 1 2 and 3, 1 2 and 3, 1 2 and 3. Okay, so f2 is this one. So 1 goes to 1, and we have 2 goes to 3, and 3 goes to 2. So now apply f2 on this one also. So 1 goes to 1, this is 2 goes to 3, and we have 3 goes to 2. So we have the f2 is f2 operation f2. f2 operation f2 is f2 square. This is 1 2 and 3, 1 2 and 3. So here 1 goes to 1, 1 goes to 1. This is 1. 2 goes to 3, and 3 goes to 2. This means 2 goes to 2. 3 goes to 2, 2 goes to 3. This is nothing but identity element. So this is an identity element. So inverse of f2, inverse of f2 is nothing but f2. Okay. Now let us find similarly f3 square, f3 operation f3. Let us find this f3 operation f3. 1 2 3. This is 1 2 3. This is also 1 2 3. Okay, so in f3 we have 1 goes to 3, 2 goes to 2, and we have 3 goes to 1. Let us apply f3 again. So we have 1 goes to 3. Okay, and 2 goes to 2, and 3 goes to 1. So we have f3 operation f3. Okay, this is 1 2 and 3, 1 2 and 3. So 1 goes to 3, 3 goes to 1. 1 goes to 1, 2 goes to 2, 2 goes to 2. This is 2 goes to 2, 3 goes to 1, and 1 goes to 3. This is also identity element. So this means this is identity. So this means f3 inverse is equal to f3. So these are self inverses. Okay. Now let us find this for f4. Let us apply f4. Again we have to apply f4. Okay, this is 1 2 and 3. This is 1 2 and 3. This is 1 2 and 3. Okay, so let us apply f4. So 1 goes to 2, and we have 2 goes to 1, and 3 goes to 3. Let us apply f4 again. So 1 goes to 2, 2 goes to 1, and 3 goes to 3. So this means f4 operation f4. f4 operation f4. 1 2 and 3. This is 1 2 and 3. So 1 goes to 2, 2 goes to 1. This means 1 goes to 1, 2 goes to 1, 1 goes to 2. This is 2 goes to 2. This is 3 goes to 3. This is nothing but identity elements. So inverse of f4 is f4. So inverse of f2 is f2, inverse of f2 is f2, inverse of f3 is f3, inverse of f4 is, sorry, this is f4, inverse of f4 is also f4. Now let us calculate f5 operation, f5 operation f6. Let us find this f5, and after that, sorry, first we have to apply f6, and after that we have to apply f5. 1 2 and 3, this is 1 2 and 3, 1 2 and 3. So f6, this one is f6, 1 goes to 2, 2 goes to 3, and 3 goes to 1. Let us apply f5. Okay, so f5 is, sorry, f5 is being applied on f6. So first we have to apply f6. Now f5, so this is 1 goes to 3, 2 goes to 1, and we have 3 goes to 2. So this one is this is f5 operation f6. So 1 2 and 3, this is 1 2 and 3. So 1 goes to 2, 2 goes to 1, this means 1 goes to 1. 2 goes to 3, 3 goes to 2, this means 2 goes to 2. 3 goes to 1, 1 goes to 3, this is 3 goes to 2. This is nothing but identity element. So this means f5 operation f6 is equal to identity. This means inverse of f5 is equal to f6. And similarly, inverse of f6 is f5. Okay, so all the elements are having its inverse. Okay, we will discuss further in next particular lecture. Thank you.